Here's an example of using the limit definition of a derivative to find the derivative of a quadratic function. In this case, f of x is equal to x squared plus 2x minus 3. Once again, I have written down the basic definition for us. That is, the derivative f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Again, that fraction is the slope of a secant line, and by adding the limit, we are able to find out what the slope of a tangent line is at a specific point on the graph of the function. So let's start by making our substitutions. We're going to have the limit as delta x approaches 0 of x plus delta x squared minus 2 times x plus delta x minus 3, and actually that should be plus 2. We'll put some brackets around there, and we'll subtract the original function, x squared plus 2x minus 3, making sure I get my signs right this time, and we'll divide all of that by delta x. If we expand out what we see in the numerator, we're going to have the limit as delta x approaches 0 of x squared plus 2x delta x plus delta x squared. And whenever you multiply delta x's by each other so that you get delta x to some power, you should use parentheses around it. Squaring the term delta x is different than having a delta x squared term. Something you see in statistics if you've maybe taken that course. So we need to be a little bit careful about how we deal with that, and it makes the algebra go a little bit better. From there, we're going to have 2x plus 2 delta x minus 3. And then when we subtract on the other side, we're going to get a minus x squared, a minus 2x, and a plus 3. Makes for a very long and complicated numerator here. But as we'll quickly see, it does clean up at least a little bit. So we're going to have the limit as delta x approaches 0. We have an x squared and a negative x squared. We have a 2x and a negative 2x. We have a negative 3 and a positive 3. So we can eliminate all those terms. And then notice what's left here. We have this 2x plus delta x term. We have a delta x squared term. And we have a 2 times delta x term. Each one of these terms has a delta x in it. So let's factor that delta x out. So we get delta x times 2x plus delta x plus 2, all divided by delta x. And then we can cancel that common factor delta x top to bottom. That will give us the limit as delta x approaches 0 of just 2x plus 2 plus delta x. Just rearranging those last two terms, we're adding them so we can add them in whatever order we want. So the only term that gets affected by the limit is the actual delta x term. It's going to go to 0, it's going to disappear. So we're going to be left with 2x plus 2. That's what f prime is. And given any x value at any point on the original function, f of x is equal to x squared plus 2x minus 3, we plug that x value into 2x plus 2, and we immediately have the slope of the tangent line at whatever point that we're interested in. So for example, if we took an x value of 1, then our f of 1 value would be 1 squared plus 2 times 1, or 3, minus 3 would be 0. And f prime of 1 would be 2 times 1 plus 2, or 4. So at the point 1 comma 0, the slope of the tangent line is 4.